For this lesson, we are going to look at the definition of an ellipse, hyperbola, and parabola given a locus of points. So what does that mean? Well, given 2 points, F1 and F2, which you can see here are the foci, an ellipse is the locus of points P such that the sum of the distances from P here to F1 and to F2 is a constant. Notice up here we have the sum of the distances. So let's go ahead and animate point P and see what happens. Notice that as point P is going around and around, the sum of the distances does not change. That's a constant. So I can stop this anywhere. Notice that the distance from P to F1 is 3.3, and in this case it's 2.652, but still the sum is 6. And if I move it over here, this one gets smaller, this one gets bigger. So again, the locus of points forms an ellipse. Let's look at a hyperbola. A hyperbola is the locus of points P, and here's P, such that the absolute value of the difference between the distances from P to F1 here and from P to F2 here is a constant. Notice up here we have the distances measured and we take the difference. And remember that we just look at the absolute value of the difference. Let's go ahead and animate this one and see what it looks like. Again, notice no matter how we move point P, whether it's here or all the way down here, that difference between the distances remains a constant. Finally, let's look at a parabola. A parabola is the locus of points P such that the distance from P here to a point F, which is the focus, is equal to the distance from P to a line L, which is the directrix. Let's go ahead and animate this one and we can see what happens. Notice that up here our distances are the same from point P to the focus and from point P to the directrix. And this is how we get a locus of points to define an ellipse, a hyperbola, or a parabola.